All right, so this is a 7-6, and what we're going to talk about in 7-6 is going to be the inverse trig functions. So this is going to wrap up the introduction to all the trig functions that we're going to deal with. But before we get into that, what I want to do is we're going to talk a little bit about the trig functions that we actually already know, and being able to see the graphs and see how these how the inverse functions work. So we've talked a little bit about the sine graph, but what we haven't talked about is domain and range. And I know this is it's a tough concept for a lot of you to understand, so I'm going to do it graphically for you. What we need to remember is that domain is always going to be it's basically the x values. It's the x values that are possible for a specific function. And the range is going to be the y values that are possible. So we have to remember that. So when we're looking at a sine graph, I have it on a calculator here. So the sine graph is already graphed here. What you need to understand here is that if you look at your x values go on forever. It keeps going left and right from negative infinity all the way to positive infinity. Basically what you're looking for is there any x values that cannot be used? And that is, there's none. So therefore our domain here is just all real numbers. And that's the domain because all x values are represented. The range is going to be the y values that are represented. So if you see this, we've already talked about how we always go from positive 1 down to negative 1. So when we identify our range, it will be negative 1 is less than or equal to y, which is less than or equal to a positive 1. And that's how we come up with what with the domain and the range. So with cosine is going to be the exact same thing. I'm not going to bother graphing that for you. But cosine is the exact same thing because we're still going to have all real numbers for our domain, and our range is still going to be negative 1 is less than or equal to y, which is less than or equal to 1. All that means is that y is in between negative 1 and 1. Now when we get to tangent's a little bit different. I want to show you the tangent graph because we haven't really done this yet. Okay, so we want to select the tangent graph, we're going to unselect the sine graph, and then we're going to go to the actual graph. So here, you see an interesting graph here where we have all these lines that are kind of swirling. And what is actually happening here is we have undefined values at each one of these intervals. And if you think about it, if we go back to talking about tangent, remember tangent is equal to sine of theta over cosine of theta. So if that's the case, wherever cosine of theta is equal to 0, that's going to be undefined. So because it's undefined, we're going to have asymptotes at each one of those. So what we do is we define the domain because it can't be every x value anymore. Every time we hit one of those asymptotes, that x value is not defined. So we define our domain as a tangent as theta cannot equal, and then we say pi over 2 plus, and we're going to say n pi. And what that means is that pi over 2 we know for sure is undefined because that's what makes cosine equal to 0, is pi over 2. And then every pi after that is also undefined. Okay, so we put that n there because we can say 1 times pi, 2 times pi, 3 times pi, 4 times pi. It can be any number put in there, but it doesn't matter. As long as we're adding pi or any multiple of pi to that, it's going to be undefined still. And for our range, if you look, we have lines that are going all the way down and all the way up. Therefore, every y value is represented. So we say that our tangent range is going to be all real numbers. So now when we look at our cosecant and our secant, it is very similar to our domain and ranges of our sine, cosine, and tangent, except one small difference. Remember, the cosecant and secant is basically we're doing 1 over. We're doing 1 over. So cosecant is 1 over the sine. Okay, so cosecant is 1 over the sine of theta. So here again, wherever sine of theta is equal to 0, that's what the limitation is on our domain. So sine of theta is equal to 0 at 0 and every pi after that. So therefore our domain would be theta cannot equal, and then it's just going to be any multiple, that's where the n comes from, and then pi. So 1 pi, it could be 0, so we put in 0, we get 0. We put in 1, we get pi. We put in 2, we get 2 pi. We put in 3, 3 pi. And every single pi after that will be undefined because that's what will make the bottom of this fraction 0, which makes it undefined. And then when we look at our range, if we were to put it in here, and we'll do that real quick here. We'll just clear this one right here. If we do 1 divided by the sine of x, you'll see quite a different graph here. So it's almost like opposite. We've already determined that our graph asymptotes here are what we've already defined, every pi. But as you notice, now it looks like our graph goes from 1 up to infinity and -1 down to infinity. So the only thing that's not included here is in between a +1 and a -1. So that will cause our range to be y is less than or equal to -1, or y is greater than or equal to 1. And that defines our range. It starts at -1 and goes down, and it starts at +1 and goes up, and nothing in between it. Okay? So now secant will be done almost exactly the same way, except because it's 1 over the cosine of theta, we're looking for where cosine is equal to 0, which we've kind of already determined here. So our domain here is going to be theta is not equal to, and we start at pi halves, and then any pi after that. So it's not equal to pi halves plus n pi. And again, that just means that you can add pi, add pi, add pi, add pi, or subtract pi, subtract pi, subtract pi. And all of those will be undefined on secant. And then the range is going to be the exact same thing as it was with the cosecant. It's either y is less than or equal to -1, or y is greater than or equal to a +1. Okay, and again, you can graph that in your graphing calculator, put it in as 1 over cosine of theta to kind of see that. So moving on from there, that kind of gives us an idea of what our graphs look like there. So, and what our domain and ranges would be. So let's talk about the interval notation. We talked a little bit about this in class, but just pay attention to the interval notation. What this means is this is where our graph is going to be defined. So on this one, it means x is going to be in between 0 and 360. Here it means that x has to be in between 0 and 2 pi. Here it means that that x is going to be in between 5 and 10. Now, make sure you pay attention to these and these. In this case, it means that 5 is not included in the graph, but on this one, it means that 10 is included. So if it has an equal sign on the bottom, it means that it is included in the graph. Okay? So just get used to this because it's going to be important moving forward because it defines where the graph will be and where we're going to be showing the graph. So now let's talk about inverse functions. Inverse functions, we're just going to write them out here. We have inverse sine of theta equals y. We have inverse cosine of theta equals y. We're just defining these, what they look like. Inverse tangent of theta equals y. Now, what do these mean? Because we're going to see a lot of these. What this means is that if you have the inverse sine of theta equals y, then what we would rewrite this as is we would say that's the same as saying the sine of y equals theta. This one, cosine of y equals theta, and this one, tangent of y equals theta. What does that mean? Well, it means that whenever we're given an inverse of something, we can figure out what the theta is by just simply taking the inverse of it. So inverse tangent of theta equals y. Well, normally we'll be given what the y value is, and then we can figure out what our theta is by just doing the inverse operations. And you'll see that when we do a couple of examples here in a minute. So let's flip the paper over here, and let's start looking at some of these graphs. So this first graph here that's the regular sine graph, and we're very familiar with this. But what we want to do is we want to make sure that we define. We're going to talk about what the inverse sign would look like. Well, here's the first thing that we need to make sure that we understand. The only way that an inverse sign can be used is if the domain of the sine function is in between negative pi halves and pi halves. The inverse sine function is not defined outside of this. It has to be in between here. So basically what we're looking at here is we know that negative pi halves is about right here and positive pi halves is about right here. So that means that this little line right here in between, that's the only place that the inverse sign can be defined. So let's define that right now. The inverse sine of theta, the domain has to be, and again, we're going to reverse this completely. So think about the range of signs. The range of sign is -1 to 1. So now that's going to become the domain because it's complete inverse. We reverse everything. So -1 is less than or equal to x, which is less than or equal to 1. And the range is going to be the exact same thing as the domain, except now it's going to be with a y value instead. So we have negative pi over 2 is less than or equal to y, which is less than or equal to positive pi over 2. And again, we can show that on the graphing calculator. And again, we will just go down here. I'm going to get rid of the one that's already here. So let's put in inverse sine of x. And what you will see is it almost, even though it's really hard to see because of how big our graph is, it's a sideways sine graph, but only defined between negative pi over 2 and positive pi over 2. Okay? And we can look at this a little bit more while we're in class. Again, don't look too much into this, but this is how it's defined. So now when we go to cosine, cosine's a little bit different. So for the inverse cosine to be defined, our domain has to be in between 0 and pi. So this shifts a little bit. So that means it can only be defined from here to here. So you can see this curve the way it is. That's where our inverse cosine is defined. So again, let's define the domain and range of this. So inverse cosine domain would have to be, again, same as the range of the cosine, which is -1 is less than. Okay, and this will actually be theta, I'm sorry. And this should have been theta over here. It's not that big of a deal, kind of the same idea. And the range will be the exact same as the domain up there, which will be 0 is less than or equal to y, which is less than or equal to pi. Okay, let's do this last trig function here. So this is our tangent. So if you look at our tangent function, again, if we define the tangent function, if we want a inverse, then the domain has to be, and this will be the same as it was for the sine. So negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. So that's the domain that has to be defined for us to have an inverse tangent. So then the inverse tangent will become, our domain is what the range is for regular tangent, which was all real numbers, and that stays all real numbers. And the range will be the same as the domain there, because remember, we're just reversing everything. So negative pi over 2 is less than or equal to y, which is less than or equal to positive pi over 2. Okay? So what we're going to do is, I'm running out of time. I didn't realize this video would take so long. I apologize. But we're going to start a second part to this. So part 2 will be these last 2 slides. Will be very, very brief. So go ahead and, you're done with this one, but don't forget to watch part 2 to finish off these notes.